Hello everyone, back tuning into the 4th Winter 2019-2020 update from GWV. So done 3 updates so far. We're already 4 updates in with this update. So we started the winter updates on the first day of September, and I think they've been pretty interesting updates so far. Really long updates. The last one was far too long, really. It came out at 1 hour 8 minutes. I've got 52 tabs open this week, so for the 4th update. That's down from, I think it's around 80 or 78, 79 that we had last week for the 3rd update. So this should, in theory, come in a little bit short. I'm certainly aiming to bring this in under the hour mark. So we'll see how we get on as we progress. So we're going to go through the methodology, of course, through this update. I'll talk you through all of the latest developments over the past week with the things that we look at in winter updates, and we will have reanalysis this week for the summer. We're going to start looking at summer 2019. Of course, we signed off on the signed off last week with the 3rd update with a little bit of summer pattern matching, but this week we're going to go on to actual summer data, and we're going to look at the summer centering temperatures and summers that were similar in terms of the CET to summer 2019 and the winters that followed them. That'll be in the second part of the video. A lot to get through before we get to that. So just to say, this is going to be a long video as always with the winter updates, so get yourself a cup of chai, get yourself a cup of tea, and we'll be here for a little while, so maybe a few nibbles will be needed along the way. Now, big thank you to James Ackwood, of course, our analogs guru, for getting all of the analogs together, and also the solar tracker. That's where we're going to start very shortly with solar activity. So, as ever, big thank to James Ackwood, big thank to Richard Trott for the GWV's Winter 2019-2020 updates GIF. I think that's everything I'm going to tell you. Just say that the video will be placed on the Winter Updates forecast page with a written summary this evening, probably around 7 or 8 o'clock, something like that. It'll probably be quite late, because I'm going to do a live chat about this winter update on the GWV's YouTube channel. So they've gone down quite well. We're doing a live chat between 5 and 6 o'clock every week to coincide with the winter updates. We seem to be building up a little bit of the following with those live chats. There'll be another one between 5 and 6 o'clock tonight. That makes me a little bit late, though, getting the winter update onto the winter updates page with a written summary. So probably be like 8 o'clock, maybe a little bit after that this evening. There's also going to be the Ecmwf, Metro France and DWD long range update coming up for you this afternoon. That'll probably be around 3 o'clock, something like that. So a very busy day at GWV's today. Alright, so I think that's everything that I've got to tell you, and without further ado, I reckon we better get on with the 4th Winter 2019-2020 update. Of course, the winter forecast will be released on the 1st of December. We announced that in update number 1, but just to reiterate that this is all building up to the winter forecast on the 1st of December. Right, so let's start the video then, and we're going to start off with solar activity. So this is how the solar disk is looking on our side of this today from solarham.net. We are spotless. Again, today there's no visible sunspots on the solar disk, and therefore solar activity is at very low levels, and it's expected to remain at very low levels for the next 3 days at least. This is GWV's 4th winter update solar activity tracker, updated by our good friend James Ackwood up to the 21st of September, and it confirms that solar activity is at very low levels. The thick green and thick red lines are our trend lines, and the orange line is depicting each individual day's sunspots. So you can see how the trend lines are sort of flatlining on the bottom of the chart now, and really on the floor of the chart, and just flatlining away. Have an occasional day with a sunspot, one just there, for example, and another one just there, but they're very much in the minority. The days that don't have sunspots are very much outnumbering the days that do, and this tells us that we have dropped definitively into solar minimum. It looks like that drop into solar minimum occurred back in May, actually. So before that, we was getting quite a few days with sunspots. The days that had sunspots before May were outnumbering the days that didn't, but that's reversed, that's flipped, and now the days that don't have sunspots are outnumbering the days that do. So at solar minimum, and we're going to be staying at solar minimum for this winter, I would have thought. Of course, we never know when we're going to end solar minimum and begin the new solar cycle, but even if we was to go into solar cycle number 25 through the course of this winter, we will still be talking about a very, very low level of solar activity. I suspect this is going to be the final winter of solar cycle 24. This will be our solar minimum winter, and before too much longer you will see analogues and reanalysis for solar minimum winters, and we'll be bringing that for you in a future update, but will be a little bit of a solar special as well. So that'll be later on in the winter updates. But I think it's going to be the solar minimum winter of solar cycle number 24. Big thank you to James Ackman, of course, for updating the GWV winter update solar activity tracker, and we'll be keeping you updated with this week by week over the course of the winter updates. To the oceans next. So this is how the oceans were looking last week when we did last week's third winter 2019-2020 update. We've got our 3 areas of interest. We've got the equatorial Pacific Ocean just here, the ENSO region. We've got the northern Pacific Ocean over there, and then we've got the North Atlantic Ocean just there. So that's how the oceans were looking last week when we did the first winter 2019-2020 update. This is how the oceans are looking right now. Very little change in terms of the equatorial Pacific Ocean. It's really, really strange what's happening in the ENSO region. So if I go back and again highlight last week's, highlight the ENSO region from last week's winter update, that's how things were looking. If we go forwards to the latest, if anything, the sea surface temperature anomalies have got colder through that eastern part of the equatorial Pacific Ocean anyway. So let's change the colour. Around here, I think they've got colder, and possibly got a little bit colder just there as well. That's sort of stretching out into the middle part of the equatorial Pacific Ocean. What do we think? I think we can say that those sea surface temperature anomalies have got a little bit colder over the past week. That, you would look at that and think we're going into a La Nina, wouldn't you? So on the face of it, that signature does look very very La Nina-esque. We've got these colder than average sea surface temperature anomalies just here, albeit a weak La Nina, but we've got weekly cold and average sea surface temperature anomalies just there. It connects down to quite a massive cold and average SSTs off the coast of Chile, going out into the southern Pacific Ocean. And you just look at that and think that looks very sort of typical of a weak La Nina that's evolving. But I'm going to show you some more data for the ENSO region in a moment. It is a very, very confused picture what's going on here and where we're going to be with this winter in terms of ENSO. Going further north into the northern part of the Pacific Ocean, that's how things were looking again in the northern Pacific last week. So all of this area just here, and particularly focusing on this northeastern corner where it is, of course, very, very warm with sea surface temperature anomalies at the moment. This is the latest. There's not really been all that much change over the past week, but possibly it has cooled a little bit, especially around there. You do actually have a little splodge of blue there. That's a tiny little area, slightly cooler than average. That's developed a little bit over the past week. I mean, it is still significantly warmer than average, don't get me wrong, in this northeastern part of the Pacific Ocean, but possibly the peak of those temperatures occurred a few weeks back, and maybe, but it's starting to cool down a little bit right now. We'll keep a close eye on that over the next few weeks and through the next updates. And at some point with these winter updates, I want to focus specifically on that northeastern part of the Pacific Ocean. We'll go through the sea surface temperature anomaly maps at NOAA, and we'll go through them all the way back to the 1980s if we can, and see how many years we've had those warmer than average SSTs up there and what the winters were perhaps like that followed them. Over in the North Atlantic, again, this is how things were looking last week. So a relatively warm North Atlantic this time last week around here, and also down to the tropical Atlantic too. The very latest is looking like that. So sea surface temperature anomalies are perhaps cooling a little bit in the northern Atlantic Ocean. So around here, we're possibly cooling down a little bit. Notice also we're starting to get some slightly colder than average sea surface temperature anomalies around Newfoundland. We need to keep an eye on that. Back in the summer, of course, we had the tripole, which was the warm over cold over warm freeway band like that, but actually the warmth, it was a classic tripole because the warmth did extend down the eastern coast of America. For a classic tripole, you want your freeway bands to be like that, and then to be like that, and also like that. So that area wants to be cold, kind of like from the eastern seaboard of America to Spain and Portugal, then warmer up here, and then of course warmer down there as well through the tropical Atlantic Ocean. We didn't really have those cold and average sea surface temperature anomalies around the eastern seaboard of America, so that's the one thing we was missing back in the summer. But we might just be starting to generate some slightly cooler sea surface temperature anomalies around the Newfoundland area. So keep a close eye on that. Also down here, of course, that is going to be related to hurricane activity, what we have down there. That's probably related to Dorian and other storms and hurricanes. But we'll be keeping a close eye on the eastern seaboard of America, I think, over the next few days. If the theory holds true, we should start to see a re-emergence of the tripole pattern as we move into the winter. So I'll be keeping a very close eye on that. This is how the subsurface temperature anomalies are looking at depth underneath the equatorial Pacific Ocean. So, of course, we've got our sea surface temperature anomalies just here, of course, in the equatorial Pacific Ocean, in the ENSO region. That's how the sea surface temperature anomalies are looking. But at depth, this is how the subsurface temperature anomalies are looking. So, if you think that with this, it's kind of like going to be the surface of the Pacific Ocean, just there, equatorial Pacific Ocean, we're going to have Peru around there, and we'll have Indonesia over here, and then means of depths 50, 100, 150, 200, 250, 300 meters, and so on. It's kind of like the floor of the equatorial Pacific Ocean down here. So that's how the subsurface temperature anomalies are looking, I should say. We've got a colder than average area subsurface temperature anomalies just there, between around 50 to 150 meters. Then we've got a little warmer area just there. That's in the shallower waters at the top of the surface, if you like, of the equatorial Pacific Ocean. And further down, we actually have a warmer area just here, kind of like between 100 and 200 meters. It's a little bit warmer there. Again, neither of those areas, warmer or colder areas of subsurface temperature anomalies, are really enough to trigger us into either an El Nino or a La Nina. So it does remain a very, very confused picture exactly what is going on in terms of the ENSO region at the moment. As I say, you would look at that sea surface temperature anomaly and think we are going into a weak La Nina, but other than the actual sea surface temperature anomaly itself, nothing else is really pointing to a weak La Nina. And the Southern Oscillation Index is crashing at the moment. So this is from Queensland Government, part of Bureau of Meteorology. SOI is depicting measuring air pressures in the Southern Ocean between Darwin and Tahiti. So when the SOI is in its negative phase, the atmospheric setup will be reflective of an El Nino, essentially. When the SOI is in its positive phase, the atmospheric setup will be reflective of a La Nina. So if the atmosphere was coupling up with the ocean, and obviously the sea surface temperature do suggest a weak La Nina, if that was to happen, we would be seeing positivity of the SY if we're going to genuinely move into a weak La Nina for the winter of 2019-2020. What's actually happening, though, you can see it quite clearly here from this red line, which is the 30-day SY average. It's absolutely crashing from where it was back towards the end of August, which was just there, virtually at neutral. Look how through September it just absolutely crashed, and it's now down here, which is close to minus 16 in terms of the SI. It's around between minus 14 and minus 16 terms of the 30-day SOI. That's a really big drop from where we was back in late August. So obviously this September has been posting some very negative returns with the SOI. These are some of our preliminary numbers. These are preliminary, they are subject to change, but they don't tend to change all that often. These two columns here are depicting the atmospheric pressures for Darwin and Tahiti, but this is the all-important column that depicts the preliminary SOI number. So for example, on the 1st of September, we're down to minus 14.32. The 2nd of September, down to minus 20.86. 8th of September, down to minus 20.92. Really negative. 9th of September, down to minus 21.51. Going further up, it gets even more negative. Look at these numbers that we have here on the 12th of September, go down to minus 24.42. On the 13th of September, down to minus 28.88. 14th September, down to minus 26.86. Again, very negative numbers indeed. But even more negative, or at least it did on one day in recent days. So the 18th of September comes out at minus 20.97. The 19th of September comes out at minus 35.30, exceptionally negative. 20th of September comes out at minus 27.75, and the 21st of September, the latest day that we have, comes out at minus 19.49. All of those numbers are reflective of an atmospheric setup that is going to be strongly towards El Nino, and I mean properly strongly set up towards El Nino, and yet we've got the sea surface temperature anomalies looking rather La Nina-esque. So this is a very confused picture. We have seen a lot of this over the years when we've done these winter updates. What generally happens with El Nino and La Nina is that you have it sorted by kind of early summer. You normally know where you're going to be for the second half of the year and into the coming winter by sort of June, July time. That's the classic situation. But over the past few years, we have seen a lot of confusion with ENSO. It seems every year now when we do these winter updates, we are sitting here talking about being very unsure until right towards the end of the winter updates exactly where we're going with ENSO. And we definitely have that again this year with so much conflict there between the atmosphere, which is very set up towards El Nino, and the ocean, which is very set up. Well, not very set up, but it is clearly, sea surface temperatures are clearly set up towards a weak La Nina type signal. This is a very confused picture indeed. This is how the modelling is looking. That's generally in favour of either ENSO neutral or even a weak El Nino. So this is CFSV2, for example. We've got the temperature anomalies on the side, the dates in terms of monthly periods are along the bottom. That's where we are right now. Sort of again, we're negative. We're not quite at a La Nina threshold. Remember, the all-important number is 0.5, whether that's below or above average. That's the level you have to be at to have either an El Nino or a La Nina designated, the all-important half a degree above or below average. So we're not quite down to that level, but we are a bit colder than ENSO neutral. That's neutral just there. But CFSV2, the black dashed line, which is the ensemble mean, that's lifting us back up towards borderline sort of ENSO neutral to El Nino, weak El Nino territory. And then the black dashed line sort of flat lines on that borderline between ENSO neutral and weak El Nino through to January, after which perhaps it drops a little bit, but staying around ENSO neutral on the warm side of ENSO neutral through to the spring of 2020. So definitely CFSV2 is indicating that we should see those sea surface temperature anomalies increasing, certainly going back to ENSO neutral on the warm side, possibly even getting towards a weak El Nino. This is how the Ecmwf is looking. This is the ensemble plume forecast. Again, same idea, temperature numbers on the side, dates on the bottom. That's the warmest, those are the warmest sort of members of the ensemble plume, up to around a degree above average. That's into weak El Nino territory. These are the coldest, going down to around a degree below average, they're into weak La Nina territory. They're outliers though. The mean sort of thrust of the ensemble plume is in that sort of area, year. So going through to the end of the year, we see that most of these ensemble members are kind of like there, which is on the warm side of ENSO neutral, somewhere between ENSO neutral and possibly a weak El Nino. I mean, there's a little bit more scatter as we get into the early part of next year. But notice where we're starting off at. Again, we're down here, and generally the ensemble plume is seeing an increase in sea surface temperature anomalies through this autumn. But there's very little sign of that at the moment in terms of the actual sea surface temperature anomalies themselves. And this is Jamstech, and it's the same idea. Again, we've got the temperature anomalies on the side, we've got the dates in terms of month periods on the bottom. We're starting off around there, which is very much ENSO neutral. The red line is the ensemble mean. That's lifting up and going into weak El Nino territory for the winter of 2019-2020. Jamstech is forecasting that this winter will actually be a weak El Nino winter, kind of similar to what we had last winter. So it is such a confused picture at the moment. Nothing is pointing towards a weak La Nina other than the sea surface temperature anomalies themselves, which to me, and I don't know about you, let me know what you think to this in the comments, but to me that does look like a signature for a weak La Nina, but nothing else is saying that that's what's going to happen. The SOI is very much towards El Nino. All of the model output is towards either being at ENSO neutral on the warm side or possibly to weak El Nino. So quite what's going on here. I can't remember seeing anything quite this confused over the years we've been doing these winter updates. Although, as I say, over the past few winter updates, we have had a lot of confusion about ENSO, and it has always been late on before we've been able to bring you our ENSO analogues towards the last couple of winter updates. I suspect that will be the case again this year, because we're not going to be able to bring you those ENSO analogues whilst there's so much confusion going on. Right, let's get on with the rest of the video then. We're going to go on to 2019 Atlantic hurricane season activity next. So this is the 2019 Atlantic hurricane season page from Wikipedia. And these are the numbers that we currently have. Everything has gone up from last week. Again, this hurricane season is taking off, seemingly. So at the moment, we're standing at a total of 11 depressions, tropical depressions. We have a total of 10 tropical storms. We have a total of 4 hurricanes, and we have a total of 2 major category 3 or above hurricanes. Week by week, these numbers are gradually increasing. They're gradually lifting up. So after a very quiet start to the 2019 Atlantic tropical storm and hurricane season, things are gradually taking off, and I would suspect those numbers will go up further when we do next week's 5th winter 2019-2020 update. So we'll see what happens there. I want to go on to the QBO next. There's been a little bit of news about the QBO, but I've seen on Twitter. I just wanted to talk a little bit about this. So the quasi-biennial oscillation, of course, is an index that's reflecting the strength of the zonal westerlies, essentially the zonal flow, if you like. So when you're in a westerly QBO, then the zonal westerlies will be strengthened. When you're in an easterly QBO, the zonal westerlies will be weakened. They'll be in a weakened state when you're in an easterly QBO. So it's very crudest. A westerly QBO kind of increases your chance of a mild winter, and an easterly QBO increases your chance of a colder winter. It's not that straightforward, because there have been several cold winters with westerly QBO. Equally, there have been several really mild winters with an easterly QBO. Now, at the moment, we are in the westerly phase of the quasi-biennial oscillation. So these numbers here, and they go all the way back 1950s, these numbers are indicating each individual month's worth of QBO numbers, if you like. So we've got 2018 just here, starting with these negative numbers. That's the easterly QBO. When you've got those negative numbers, you're in an easterly QBO, and therefore the zone westerlies are weaker. This is particularly important for winter, less so for other times of the year. That easterly QBO peaked in the middle of 2018, and then it went into reverse through the sort of final months of 2018, going into the westerly phase of the QBO quickly by the end of 2018. This takes us to 2019 just here. See how these numbers, these positive numbers now, are increasing. They're getting bigger, and the westerly QBO looks like it peaks just there, with those 2 months going up to plus 14. Actually, that one is slightly higher than that one, but they're both kind of similar. So that looks like it's the peak of the westerly phase of the QBO back in the early summer. Since then, we have the numbers for August just there, and we have been number 4, I should say. That's going to be August just there, because we haven't got September's yet, so that is going to be July just there, and then that's September, that's October, that's November, and that's December, of course, that last one over there. So this is July's number, this is August's number. Notice how they're reducing from earlier in the summer. So that, of course, is June, and that's May. And the numbers have gone from plus 14.59 and plus 14.36 there to plus 10.96 and plus 9.97 just there. Looks like the westerly QBO has peaked, and we're beginning to shift towards an easterly QBO. If that was to carry on in a reducing fashion, you expect that number to be less for September, and then again in October, and then possibly November or December would take you through to a negative number maybe. Not quite that straightforward though, and we have been hearing a little bit about what's going on in September. This is something new. I haven't shown you this in any winter update or any other video before. This is from NASA, and it's depicting Singapore's zonal winds. So it's depicting the easterly and westerly phases of the QBO. In fact, if you scroll up here, you can actually see them going through the years, through the decades back to the 1980s. The blue coloured areas are where we've got the easterly QBO, and these sort of sandy coloured areas where we've got the westerly QBO, and you see how they alternate, almost like a pulse, should be very, very regular. You see how they alternate through the years and through the decades. But this is showing actually individual days QBO numbers. This is updated to Saturday 21st of September when we're doing the video just here. So remember, the grey area, we've got the westerly QBO, so that's going to be a westerly QBO just there from 2016 through to 2017. This blue area just here is where we've got the easterly QBO. That's from 2017 into 2018, of course. This is our latest westerly QBO just here from 2018 through to 2019. Now you'll notice this blue area up here, that's the beginnings of the easterly QBO starting to descend down in the upper levels of the atmosphere. So we've kind of got got 10 HPA just there. So that's right at the top level of the atmosphere in the stratosphere. This is down on the surface. The all-important boundary layer where we've got to get both the westerly and the easterly QBO phases down to is kind of like between 30 and 50 HPA. That's the troposphere in the mid-level of the atmosphere. So back in the summer, you'll see that we was beginning to get the start of the easterly beginning to get start of the easterly QBO at the very top of the atmosphere, but at the moment that is not moving downwards during September. This is the month of September just here with the data. The moment this is not moving down into that sort of, let's come over here, 30 to 50 HPA level. It's being kept up at around the 10 to 20 HPA level, and you'll notice that underneath it, the westerly QBO, this sandy coloured area, that's continuing. There's a little bit of concern I've seen on Twitter and elsewhere, but this could be, excuse me, this could be a sign that the easterly QBO is failing again. If we come up here, you'll remember what happened during 2015-2016. So we had the easterly, we was in a westerly QBO, of course, for the winter of 2015-2016. Depicted by that area just there. We had the easterly QBO beginning at the top of the atmosphere during early 2016. It should have moved down into a troposphere, but it didn't. It was kept up at that top level of the atmosphere, and so the westerly QBO just continued through 2016, even into 2017. It wasn't until the second half of 2017 that we finally started to propagate the easterly QBO down, and we did go in then to a proper east QBO during 2017-2018. But we had that failure, the failure of the easterly QBO from 2015 through to 2016, and then from 2016 to 2017. It's the longest recorded westerly QBO phase that we've ever seen. Now, there's a bit of concern that what's happening at the moment could be a sign that the easterly QBO is going to fail again. All I'd say about that is that, of course, 2015-2016 was the Super Nino. We had a Super El Nino going on. We never knew whether that was what caused the failure of the easterly QBO, but it's possible that that's what caused it. And sometimes when we have these transitions from westerly to easterly QBOs, they don't always go all that straightforwardly. So I want to scroll back through the years. I'm going to take you up to 1978, 1979. Just there, that's 1978, that's 1979, just there. So 1978 was a westerly QBO year. You'll see how the westerly QBO sort of increases and strengthens through the first half of the year, reaching its peak around here. So that's kind of like going to be April and May, reaching its peak in April and May. Then through June, July, August, we see that westerly QBO begins to weaken. And you will think that, again, that westerly QBO is starting its transition to an easterly QBO. But then what actually happens is that we get to there, and we see the westerly QBO beginning to strengthen a little bit. And that strengthening signal actually carries on to that number just there, which is October. Then it reduces again a little bit through November and December of 1978, but still staying in westerly QBO phase. The very, very weak westerly QBO did in fact hang on into the opening months of 1979 as well. So that very cold winter of 78-79 was actually a very weak sort of dying a death westerly QBO winter, a westerly QBO that's hanging on by its fingertips. That was what was going on in the winter of 1978-1979. And even though seemingly the first sort of movement towards an easterly QBO started there in 1978, it actually wasn't until that number just there, April of 1979, that we finally went into the easterly QBO, and that of course strengthened them through 1979 and into 1980. Another example of this that I've seen is 2013, 2014. So let's have a look if we can just here. So there's 2013 there. You see we start off with an easterly QBO, then we go into a strengthening westerly QBO through the summer of 2013. It starts to reduce just here, so it reaches its peak in those two numbers, those 2 months I should say, plus 14. Then it starts to reduce there, down to plus 13, down to plus 11. But then it starts to strengthen again, just there, and then again down here into early 2014. It's not until we go off into the summer of 2014 that we start to go into the easterly phase of the QBO. Now, sometimes this does happen in a more linear fashion. So this is 2016, 2017. So we start 2016, of course, with that ongoing westerly QBO, but just wouldn't go away. It began in 2015. It just wouldn't go away. It carried on into 2016 through the year, and we go to 2017, and you'll see that in this example the QBO is reversing to the easterly QBO in a linear fashion. So we go in December 2016 we go to plus 15.09, 2017 we go to plus 14.92, January 2017, I should say. February 2017 is plus 14.78. February March is plus 14. April plus 13. May plus 8, and then June is the month that goes into the ECQBO, goes negative, minus 13. So that does it in a much more linear fashion. So you can sometimes find that the westerly to ECQBO will happen in a linear fashion, but not always. Sometimes the westerly QBO will kind of weaken a bit and then strengthen and then weaken again. Sometimes you'll just get a very weak westerly QBO just hanging on by its fingertips. So I suspect what's going to happen with September, we haven't got September's number just yet, that will be put in just there of course, but I suspect what will happen with the QBO number for September 2019 is that it will probably be similar to August. It may even be a little bit more westerly. It may actually be a slight increase on August, and that could carry on into October, and then November, December might find that we start to shift towards the easterly QBO. But I wouldn't be too concerned about what the QBO is doing. I think we've proven the point that just because the easterly QBO is at the moment stuck at the very top of the atmosphere, the easterly QBO is stuck at the very top of the atmosphere, doesn't necessarily mean that eventually it won't propagate down and we won't go into the easterly phase of the QBO. Right, North Atlantic oscillation observed and forecast. So just to bring you an update of what's happening with that. The black line shows where we've been with the NAO. Red lines at the end where GFS Ensembles forecasting the NAO to go. Being in a prolonged negative phase of North Atlantic oscillation. At the moment, we're around ENSO neutral. And looks like the NAO is going to be going negative as we go through the closing stages of September. And probably still negative even into early October. That period just there. We do have that ensemble member that's lifting up into positive territory. Generally, though, it looks like the NAO is shifting back towards a more negative phase, which, of course, is where it was up to the middle of August. And then from the middle of August, the NAO went into a rather more positive phase and carried that positive, slightly positive phase, carried on into the first half of September. It looks like it's shifting to a more negative phase at the moment. This is the Arctic oscillation. Remember, these indexes are just reflecting the atmospheric state in the North Atlantic and in the Arctic. They're not driving anything in terms of their own terms. The Arctic oscillation is actually more definitively positive. That's where it is right now, just on the positive side of neutral. Going to go really quite positive over the next few days, then possibly drop back a little bit towards neutral as we go through to the beginning of October. I think it's the NAO that we have to keep an eye on at the moment, rather than the AO, which is a little bit of a reverse. Normally it's the AO that's prone to go negative, but it looks like it's going to be the NAO. It's going to be shifting out of the two indexes. This is from weatheriscool.com, and it's depicting the strength of the zone of winds at 10 HPA. So I've just talked about 10 HPA in terms of the QBO. That's the top level of the atmosphere in the stratosphere. So we're in a period of the year when the zonal winds at 10 HPA in the stratosphere should be strengthening, should be becoming stronger. What's actually happening at the moment, although they are strengthening, of course, because we're going into the Arctic winter, it's weaker than average. So there's lots of different coloured lines on this chart. I haven't got time to go through them all, but we do explain what each individual line is showing in the first winter update. So go back to that, release on the 1st of September, and have a look. The black line is the trend line for this time of year. We are in a strengthening period of the year for the zonal winds. The blue line shows where we've been through this season so far. And the green lines are the GFS ensembles, what they're forecasting the zonal winds to do. So in the next day or so, actually, the zonal winds are going to be around average. But you'll notice that as we go into more extended range, it looks like the zonal winds are becoming quite weak again, actually, as we go into the early part of October. That's the month of October just there, of course. That's going to be November just there, and that will be December just there. These other coloured lines are from the CFS V2. They're generally depicting the zonal winds to become a little bit stronger through October and into November. This is the strongest we've seen the CFS forecasting the zonal winds. through this order. So it does look as though the polar vortex, and of course the polar vortex at its roots is at 10 HPA in the stratosphere. It does look as though the polar vortex will be strengthening over the next couple of months, which you would expect as we go through the autumn, of course. We have got a couple of members of the CFS-V2, the 4 CFS-V2 runs over, but it look like they're going for an early southern stratospheric warming. This blue line just here is going for it kind of like early December. This pink line is going for it later in December. The other 2 pink lines are not seeing a sudden stratospheric warming at the moment. Remember, when we get a sudden stratospheric warming, we get a reversal of the zone of winds, and we'll see the zone of winds going down to that level or below, going down to 0 or even into negative territory. And that's when the zone of winds going to reverse, and it would typically happen when you have a sudden stratospheric warming. But it is interesting. We have had generally quite weakened zone of winds through this season so far, and the GFS ensembles, certainly forecasting the zone of winds to become a little bit weaker, actually, as we go into the opening days of October. This is how things look in terms of Arctic sea ice extent. So if we scroll down here, and we fill in some of the coloured lines. This is the trend line, of course, so we've got dates along the bottom just here. So we're in a declining period of the year right now, with virtually as low as we're going to go with Arctic sea ice extent as it's melted through the summer. If I put in 2019, first of all, that's where we are. So obviously it's been a very, very big melt season, as we've been explaining in the winter updates up to now. That's where we are with Arctic sea ice extent right now. If we was to put in 2012, which is the record minimum, you see we have come up short of 2012, which was the death spiral year. There's not a lot in it, though, but certainly 2012 is comfortably the lowest year for Arctic sea ice extent. We haven't beaten it with 2019. If we fill in 2018, just there, so we're under 2018, of course, last year for Arctic sea ice extent. We're also under 2017. So it's been a really big melt season, this. We're close to 2016, but actually we were now a little bit under 2016 as the refreeze was getting underway at this point in 2016, whereas you can see from that blue line that actually the melt season is still continuing at the moment. That's 2015, well under that. That's 2014, that blue line just there. And then we've got 2013, we're going further back than that. So after the death spiral of 2012, which is this line just here, 2013, 2014, those 2 years sort of rebounded a little bit, took everyone by surprise. Anyway, at the moment, this is the second biggest Arctic melt season that we have had. You can see that, by the way, that blue line sort of sticking out from all of the other coloured lines. The only other year that had a bigger Arctic size melt season was 2012. I will think this will start ticking up very, very soon. We'll look at it again next week. If it's starting to tick up next week, I doubt we'll look at this again, but a really big melt season in terms of Arctic sea ice so far this year. It probably won't go any lower, but we'll have another look at it next week. And then we've got Eurasian snow cover. So this is how things were looking last week in terms of snow cover across Siberia. Very, very shocking with that area of snow there through central Siberia. We went back through the archive at the National Snow and Ice Data Centre, and we couldn't find another year that had as much snow as that going back to 1998. The only year that was close to it was 2006. I did say at the time that we will probably see some of that melted because it's so unusual to get that much snow so early in September. I couldn't really see it being sustained. We will have a look in a moment, see what's happened over the past week. This is the Arctic sea ice, by the way, this yellow area just here where we've got this blue. That's where Arctic sea ice has melted and the sea has opened up. But let's have a look at the latest in terms of snow cover. So that's it, and clearly we have lost quite a bit of snow over the past week compared to last week. So we do still have some areas of snow, and I'll go through the archive again in a moment. Quite extensive, but nowhere near as much as we had last week through the central part of Siberia. And I did sort of think that we were likely to see that snow cover melting over the week, and that is indeed what has transpired. Let's compare the very latest. This is for the 20th September with the past year, so that's 2018 just there. We have more snow cover across Russia, across eastern Siberia and Russia than we had at this point last year. Let's run through the archive. That's 2017. We're doing better for snow cover than at this point in 2017. Way better than at this point in 2016. That's 2015. I think we're up on 2015 as well. That's 2014. We're up on that year too. That's 2013, up on that. 2012, clearly we are well ahead of 2012 for those patches of snow at this point in the year. That's 2011, we're doing better than that. That's 2010. What do you think about 2010? That's the wrong chart, let's get rid of that. So this is the latest, and compare it to, this is the latest for 20th September 2019, compare it to 2010. Probably on a par with it actually, maybe a little bit under 2010. That's 2009, we're doing better than 09. That's 08, doing better than 08. That's 07, doing better than that year too. That's 2006, I think doing better than that year too. That's 2005, doing much better than 2005 and 2004. That's 2003, which we're doing better than that year as well. 2002, we're possibly under 2002. So the 2 years we may be under for snow cover at the moment is 2010, 2002. Otherwise, I think we're pretty much ahead of all other years going back to 1998. Actually, 1998 wasn't doing too badly at this point either. So we're not doing bad, actually, for snow. Let's just move that on to there and bring the camera back up. We're not doing badly for snow at the moment, but it has you know, thawed out a little bit compared to what we had at this point last week, and I did say that was probably what was going to happen. It's very unusual to have that much snow across Siberia so early in September. It's mainly October that we focus on, see how quickly the snow line advances across Siberia and Russia. Right, I'm going to pause the video there. Talk for just over 45 minutes. Hope you found it interesting and informative so far. I'm going to pause the video there. When we return, we'll have a look at some summer analogues. So I'll see you very, very shortly. Okay, we're back and we're ready to resume the fourth winter 2019-2020 update. I hope you've been enjoying the update so far. I've gone through all of the things that we look at through the course of the winter updates. And now we're going to finish off with some analogues. So we want to start focusing on summer analogues. That's what we can do this final part of the video. So this is how the central inland temperature looks for the summer of 2019. We had June coming out at 14.2. We had July coming out at 17.5. We had August coming out at 17.1, which brings us out at around 16.2 for the summer seating for 2019. A warm summer, not a classic hot summer. Didn't have an 18 Celsius CET month, but certainly on the much warmer side. So we've gone back, and James has gone back and had a look at summers that had similar CETs, and then had a look at the winters that follow them. So we're going to go through those winters right now. The first one is the summer of 1857. So this is going to be the winter of 1857-1858, I believe. And this one is showing an anticyclonic signal for the winter. High pressure is dominating in the winter of 1857-1858. It's a high pressure dominated anticyclonic winter. Probably not particularly cold, though back then, of course, anticyclones would have generated a lot of fog and murk and smog. So it probably would have been relatively cold from frost and fog, but it's not a high latitude blocking type winter. The next winter is 1859-1860. Remember, we're looking at summer CETs close to 2019. This one a much more unsettled winter. The winter of 1859-1860 is a very wet winter with low pressure in from off the Atlantic, bringing in those strong westerly winds too. just an Atlantic onslaught type winter in 1859-1860. The next winter, following a summer CET close to 2019, is winter of 1870-1871. This one looks a little bit more interesting. It has below average heights to the south of us, and it has blocking up to the north, high pressure sitting up to our north, and we're bringing in the winds from an easterly direction with this. So that could be quite a coldish and relatively unsettled winter for 1871. The next winter is 1876-1877. This one looks mild and unsettled again. So low pressure would be driving in from off the Atlantic with jet stream doing something like that. There's no particular northern blocking signal to thaw cold air out of the pole down to mid latitudes. So it just looks like a very mild and wet winter for 1876-1877. The next winter is 1887-1888, and this is one that showed up last week when we did the summer pattern matches. So remember, this is being generated by the fact that the summer CET was close to 2019, and we know from last week that the pattern was also quite close to summer 2019. So this is perhaps a slightly more important analogue within this package. This is quite a cold winter, has below average heights to our south and east, has high pressure out to the northwest. This is also a solar cycle number 12 winter as well, late solar cycle number 12 winter. So talked about that in last week's winter update as well, the connection between solar cycle 24 and the solar cycle 12. I think that could be quite an important analogue within this package of analogues, the winter of 1877-1888. It does have a cold Christmas, a very cold Christmas to New Year from 1877. From 1870, let's go back, from 1887 to 1888. It's getting very late and I'm a bit tired. That's my excuse anyway. Our next winter, following a summer CET close to 2019, is that of 1893-1894. This one is an unsettled winter, low pressure, it's up to the north, we're feeding in the westerly winds, so this is back to mild and wet conditions. A long gap then through to the winter of 1921-1922. Again, following a summer CET in 1921 close to 2019. This one is a wet and unsettled and mild winter as well in 1921-1922. Then we go through to 1934-1935. This one is a rather strange winter. It's quite an unsettled winter, and it does have a little bit of a blocking signal as well, but it's not remembered as a particularly cold winter. I don't think. The next winter is 1935-1936. So, of course, we had a run of warm summers through the early and middle 1930s. And we have two winters on the bounce here, 34-35 and 35-36. This one is a very unsettled winter. It's a wet winter, low pressure again off the Atlantic. It does have some northern blocking mode going on within the northern latitudes. Quite a big gap again to 1949-1950, following the warm summer of 1949, of course. This one is a mild winter, bringing in winds from a westerly direction, and it's quite an unsettled winter as well. Then we've got 1955-1956 showing up next, following a summer CET close to 2019. This one with the below average heights to our south and east, above average heights out to our northwest, and we're bringing in winds from an easterly direction. The strange thing about this winter is that it's very mild in December of 1955, but February 1956 is freezing cold. It really is very severely cold indeed. Another long gap through to 1984-1985. So the summer of 1984 came out with a CET very close to the summer of 2019. The winter of 1984-85 was a cold winter. It has this high pressure sitting up to our northeast. It has low pressure to our south down here, and of course we are feeding in the wind from an easterly direction. That's a cold winter in 1985, part of a trilogy of cold winters through the middle of the 1980s. The next winter is 1988-1989. This one's back to mild and wet. Low pressure out to our west. High pressure across central southern Europe, bringing in those west or southwesterly winds. That's a very mild Atlantic-driven winter for 89-90. And then we've got 90-91. This is another cold winter. This one with high pressure centred towards Scandinavia. Low pressure out to our west. We have a very cold spell during February of 1991. Freezing cold. February 91. The next winter, following a summer CT close to 2019, is 1996-1997. This one with above average heights close to the country. It looks like a very anticyclonic winter. It has a cold start, front-loaded winter with bitterly cold easterly winds over Christmas and New Year of 96-97. Then it goes away and the rest of the winter turns mild. February 1997 is very mild and wet. 97-98 is our next winter. This is the strong El Nino winter, of course, with a big ridge from Africa up to Scandinavia and bringing up those really warm southerly winds. That's an exceptionally mild winter. 97-98 coincides, though, with a super El Nino. 2001-2002 looks like a very similar pattern to 97-98 in some ways, with lots of high pressure to our south. This is a more unsettled winter. Pretty cool in December of 2001. The rest of the winter, though, turns mild and increasingly wet through January and February 2002. 2004-2005 showing up next with a summer CT close to summer 2019. This one has high pressure, above average heights out to our west, below average heights to our south. It takes a long time to get going, the winter of 04-05, but it does eventually finish up quite cold in the second half of February and through to early March. 2005-2006 is our next winter. This looks like it should be a very cold winter because it has high pressure centred to the north and the northeast with low pressure to the south. And you would look at that and think we're bringing in northeasterly winds. It's just one of those winters that never really came together, and I was never really sure why. It's not a particularly cold winter, but again, it does have quite a potent cold spell late in February and through to March 2006. 2013-2014 next. This is a very mild wet winter, of course, horrendously wet and windy winter, very Atlantic driven indeed. 2013-2014. 2016-2017 has high pressure sitting more or less over the top of the country, so this is just a quiet, mild, dry, anticyclonic, very dull and boring winter. 2016-2017. And then finally, we've got 2017-2018 with a CT again close to, with a summer CT in 2017 close to the summer of 2019. This one, of course, has high pressure up to our northeast. It has low pressure to the east and south of the country. It gets colder as the winter progresses, and it all culminates in the beast from the east at the end of February 2018. Putting all of that together, this is how all Decembers combined are looking following summers with a CT very close to the summer of 2019. So December, it looks unsettled. It's an unsettled signal for December with below average heights, low pressure over the top of the UK and Western Europe as well. This is how all January's combined look. A little bit more interesting for January, definitely. High pressure is up to our northeast. Low pressure is, let's change colour, low pressure is to the south. So bringing in the wind from an easterly direction on average. Of course, there will be years that deviate, like January 2014. There will be years that deviate. But on average, this analogues package does give us the chance, anyway, of a much colder and much more wintry month in January. February returns to a mild Atlantic-driven signal with low pressure again over and to the north of the country, the winds returning to westerly. So after colder January, we have February looking much milder and wetter. And then March looks like it goes into an early spring type month with above average heights centred through the UK and into Western Europe. And that will be allowing us to draw up wind from a southerly or southeast direction, an early spring in March with this analogues package. Overall, this is how all winters combined are looking with a summer CT close to the summer of 2019. It's an unsettled signal for the winter overall, quite a mild wet signal generally, but it does have a little bit of blocking up to the northeast, and that's primarily down, of course, to what's happening in January. January is like the Joker in the pack that could produce something cold and wintry in an otherwise generally quite mild and wet Atlantic driven type winter. We shall look at more data for summer and the winters that follow them next week. We'll pick up exactly where we left off with this update, and we'll look at summer precipitation and find matches to the summer of 2019. Finally, if you've been enjoying winter updates at GWV just recently, then please can you consider becoming a patron for GWV. We have 62 patrons so far. Hello and a big thank you to our 62 patrons. We very much hope you've been enjoying the winter updates, and we hope you enjoyed this winter update too. You can go to Patreon and become a patron for GWV, give an ongoing monthly donation. It could be anything from $1 a month upwards. Alternatively, you can become a PayPal donor, and you do that by going to GWV's PayPal page, sign into your PayPal account, and then you can give a one-off donation to GWV. Whether you do it through Patreon or through PayPal, we give you a shout out in videos, and we'll say thank you so much for doing that. Right, and that brings us to the end of this winter update, and we've talked for an hour, so I have brought this in at an hour. I thought we'd be a little bit shorter than last week's, so I hope you found this video interesting and informative. I'm going to place this on the winter updates and forecast page with a written summary at around 8 o'clock this evening. There'll be the live chat on YouTube between 5 and 6 o'clock, where I'll take as many questions as I can about this winter update, and have a listen to that if you'd like to do that between 5 and 6 o'clock on GWV's YouTube channel. Also, coming up in a few hours, probably around 3 o'clock, we'll have the Ecmwf, Metro France and DWD seasonal model update. But at just over an hour, that's all for now, and thanks for watching.